Okay, this is worksheet 9B for the Math 4 course. Most of these are just following that one formula and doing a bit of Math 1. Let's see now, the person is 47, and the mean is 52, and the standard deviation is 2.5. So that's going to be negative 5 over 2.5. It's basically negative 2 for a z-score, which means they are 2 standard deviations below the mean. And so we plug in a 54 this time, and we get 2.0 over 2.5, which is about 4 over 5, which is more like plus 0.8. And then here we have a z-score of 1.3. We don't know what the raw score is. We do know that the mean is 52 and the standard deviation is 2.5. Now, by the time that we multiply these, we're going to multiply both sides by 2.5, so these guys cancel. And this winds up being 3.25. And by the time I add 52, I have to watch my decimal place here. I get 55.25, which means that he is 47 1/4. But he's also more than 1 standard deviation above the mean. All right, a lab retriever is 24.5. The mean is 23.5. And the deviation is 0.8. That is basically 1.0 over 0.8. That's like 5 over 4. That's 1 1/4. Okay, if he earned a 75, mean was 80, standard deviation was 6. That's going to be a negative 5 over 6, which turns out to be a negative 0.8 and a repeating 3. Okay, we have a chocolate bar with a weight of 6.13. And then 6 ounces is the mean with a 0.1 ounce deviation. That's going to be 0.13 over 0.10, which you multiply the top and the bottom by 100, you get 13 over 10, which is 1 3/10. All right, a book is 280, the mean is 350, and the standard deviation is 100. And that's going to leave you with negative 70 over 100, or negative 0.7. Now, this one we need 2 z-scores above the mean. So our z-score is positive 2. We don't know what that raw score is going to be, but it has a mean of 18 and a deviation of 6. Now, if I multiply both sides by 6, I get 12 equals x minus 18, which means that 30 is my raw score here. I had to have a little fun with the idea of North Carolina University. It's not University of North Carolina. It's not North Carolina State University. It's North Carolina University. So, you know that it's made up. I also wanted to comment that, if they're talking about 2 z-scores above the mean, that's 2 standard deviations. Now think about it. Under your normal bell curve, once you got to 2 standard deviations on either side, this is where 95% of the data is supposed to live, which means you've got 5% left on the outside. That's going to mean 2.5% down here, and 2.5% up here. So what they are talking about here is really the upper 2.5% of all scores. So yeah, that's a little on the picky side. All right. She scored 1.3 standard deviations above the mean. That's positive. We don't know the score. We do know the mean. We do know the standard deviation. By the time that I have multiplied both sides by 9, I get 11.7. Watch your decimal places there. So she got about an 82 for a score, which considered the middle of the class was 70. That's not bad. All right, they've got a mean and a standard deviation. They want to test a sample who fall between 1 and 3 z-scores above the mean. So we're going to need to figure out both of those. We're going to need to figure out 1. Standard deviation is 25. Multiply both sides by 25. I get that. Add 200 to both sides. I get that. So now I change to 3 standard deviations above. I'm still multiplying both sides by 25. And I'm adding 200 to both sides. So now, understand what this means. This means that this pharmaceutical company is testing a drug and they're checking the average cholesterol of the population. And, you know, the stuff in the middle, that's fine, but the stuff that's above the middle, that's, you know, people have too much cholesterol. And so they're looking at that group and saying, you know, this is the group that we want to target. You know, this one we want to look at especially. And so they're going to look at the ones that have between 225 and 275 on their cholesterol score. That's the sample that they want to target, because those are the ones with high cholesterol. All right, Janie and Amy, both working at a job in different departments, getting paid different things, and so we're trying to figure out who has moved further up the ladder. I guess that's one way of putting this. Relative to their departments, you know, who is making you know, better money. So we're going to start with Jamie. Jamie makes $19.75 an hour, and the mean is 1880, and the standard deviation is 320. Now that's going to be 20 plus 75 is 95 cents to the good over 320. And that's going to work out to be about 0.30 as a z-score is concerned. And so when we look at Amy, Amy gets $19.15 an hour less the mean rate of $17.50 divided by the standard deviation of 280. So that is going to be $1.50 plus 15 cents is $1.65 over 280. And that is going to be 59 cents. Or, you know, 0.59 rather. These aren't really cents. These are z-scores, which tells us that Jamie is getting paid a little above average, but Amy is getting paid a little more above average. She's further in the positive direction away from the mean. So who is better paid? She is better paid. Okay, coming down the home stretch, the last two problems. All right, so Vince is in this triathlon, and bottom line is that if we want to know what is his best event, we need to run a z-score on all three of these. So we'll start with the swim. That is going to be 14.7 minus 12.2 over 2.4. That is going to be 2.5 over 2.4. Works out to be about 104. And we're going to do the bike. Is that the blackbirds I'm hearing? Okay. Okay. All right, so we get 3.2 and a 5. And that's going to give us 0.64. And then we switch over to run, which is going to be 26.1 minus 24.5 over 4.3, which that's going to be 1.6 over 4.3, which turns out to be 0.37. Now, here's where the very first class that I did this, I looked at those and I said the 1.04, the 0.64, and the 0.37. Oh, the 1.04 is his best event because he is farthest ahead of the mean there. And then a student pointed out to me and said, Mr. G, isn't the goal here to have the smallest time? You know, if you're, competitive athletics, you want a lesser time, which means that the 1.04 is actually his worst category, and the 0.37 is his best. So I was corrected on that. If I had been in the classroom, I would have handed out a sucker on the spot. I probably, since I had already gone through and made my conclusion and stepped back from it, and then he says something, I probably would have gone and found a Charms blow pop. I usually, when we're back in the building, I will usually carry dum-dums around in my pocket. And if somebody says something that's kind of like, wow, that's good, I'll toss them a sucker. And, but if I just royally screw something up and a student catches me at it, and it's like this is going to save everybody a lot of headache by catching this now, I'll go back to my secret stash and get a Charms blow pop. So anyway, moving on. Number last, we have Eliza and Hannah taking their respective foreign language tests. And so they've basically given us all the information. They want to know which student did better. We need the z-scores on both of them. So we'll start with Eliza. Eliza scored, and one of the things about this is that both of these tests are being scored on completely different scales. And so it's really hard to compare apples and apples when you're dealing with apples and oranges. So the z-score allows us to get back to apples and apples. We can see, compared to the rest of the class, how did she do? So let's see now, Spanish 2 has a mean of 675 and a standard deviation of 50. That's going to be 47 over 50, which is going to be 0.94. So then we switch over to Hannah. And her score was a 90, where the mean was how much? 82, there it is. And the standard deviation of 6. Now, 90 minus 82 is 8. That's 4 over 3. That's 1 1/3. So clearly, Hannah had the better score compared to the rest of her class. And that is it for that section.